Hi friends, good evening. We welcome you all to this special C language course. Actually, this is very essential. Those who are thinking about seriously to learn this language, especially those who want to settle in software field. So this is our part of social service program. Through BSNK, we are offering this free course. For this, we have a instructor. He has 5+ years industry experience. So he has his master's IC technology from University of Hyderabad. His name is Ramakrishna Mandalapu. So he is our instructor today onwards, and he has graciously offered this course freely, even though he is very busy and engaged in so many activities. But as a part of charity to help society to build our nation in a wonderful way, to equip youngsters. So we have started this course. So thank you for showing your interest to join in this course. We appreciate your joining. So let's invite our instructor, Ramakrishna sir. Ramakrishna sir, we welcome you to take this course. Thank you.
Yeah, thank you. That's a very wonderful introduction. I haven't expected. Thanks, brother Anand. And I think I just want to give some brief introduction about what this course is about. Already explained by brother Anand here. So this course, as said earlier, we want to give it for free to engage people to learn new things in the era of work from home, and also the technical evolution, technological evolution, wherein we meet virtually, we can learn. So instead of physically gathering, we can just learn this through online. So yeah, we can make some time in our own convenience, and we can offer this course. And the main motive is, we want to give it for free to make many skillful people in this area of software development. So here, as I said in the group, I think you're all there. Most of you are all there. We want to, today we'll just go ahead with basics and some programming live. And from next week onwards, we'll see a lot of new things coming up, the advanced features, why C, where C, and how to use different options and different features of C effectively. So those things we'll get to know from going forward. So in the current meeting, so you're all muted because to make it more smooth, to avoid any disturbance to you and to avoid any noise to you. So we muted all the participants, and also you cannot start your video also. In order to save some bandwidth, we have did these two things. So if you have any questions, so the chat is open. You can use the chat and you can ask the questions regarding the meeting or whatsoever. Then we'll try to answer you. If it is related to the today's topics, then we'll answer your questions at the end of this presentation during the Q&A session. And also, so not only just teaching here, we'll just give you some assignments to do at your home. So if you have laptops, try to do those assignments. You can do them online as well, using some online websites. They provide you some environments to run the C programs, so you can do that there also, and you can provide solutions. So what we do is, like, today we'll just go ahead with the basics, the first day of our course, and at the end I will give you assignments. The assignment I'll just send it through WhatsApp as a PDF. All of you please go through and then do that. Yeah. So thanks for attending, all of you. Thanks for your interest so far. So 20+ people have joined, and we're very happy for all of you, and we should not stop learning. Whatever, if you knew things, we should not stop learning this thing again and again, because we can see some different ways to understand things from different perspectives. So I appreciate all of you for joining in this course, and we wish you all that you learn, see here very fluently, and then you can apply in your job and in your academics and wherever it is necessary. Not only see, but if you know these paradigms, then you can try applying them in different languages as well. So C inspired many other languages, and most of the keywords are same in many of the languages. Might be they have a different structure, but keywords will be same. You'll encounter the same keywords as there in C. So let's start without wasting time. Welcome all of you to our course. Let's see. Write effective C programs. Sorry for the different tone. I have cough and fever from past 2 days, so I couldn't have good tone now. But please bear with me. From next week onwards, it will be good for you. So write effective C programs. So we'll be learning C programming in this course, so which is free for you. So let's go ahead with the introduction to C. So I want just give you some heads up about what is C, and some history. So you don't need to memorize all these things, but I just want to give you some motivation behind discovery of the C, or sorry, invention of the C and all. So C was invented by Dennis Ritchie. He's you can see in the left side image. His name is Dennis Ritchie. He's a computer scientist. He works at AT&T Bell Laboratories, and he invented C basically. So before that, there are some other things also. B is there. After that, he invented C, and C became very popular. So it is invented by Dennis Ritchie, and it was invented at AT&T Bell Labs. You can see here many inventions came from this laboratory. So we are very fortunate that this laboratories existed for us to give a lot of inventions. So C was invented, C++ was written, and also Unix was invented. And today we are talking about mobile revolution, right? So processor revolution. We are seeing speed like anything, AI and everything. So for all that, what we require is a transistor. The transistor also was invented at AT&T Bell Laboratories. It's very great. And it was invented in the year of 1972, and so they used this computer. So this, if you're seeing, maybe it's small size for you, but it's very big. It's very big actually. It's not like our normal CPU, but it's very big hardware upon which they invented C. So its name is 16-bit DSP-DP11 computer. And now coming to the uses of C here. So the first thing is it can extend to newer architectures. Today we are talking about different architectures, right? If you're your PC running, your PC actually x86 architecture, which if it is running Intel, then if it is running it is having some AMD processor, then AMD 64. And your mobile actually that is based upon ARM. So different system architectures, it can be extended to different system architectures, the C. And efficiency and performance. So C is very efficient, and it will have high performance when we compare with other high-level languages. Why? Because it is middle-level language, and it is very nearest to hardware, or it's very dearest to hardware. No, it is low-level language. It can access processor and its memory and all the stuff. So efficiency wise, because it doesn't have any middleware, or it doesn't have any many stages in the compilation, or its compiler is actually lightweight. So we can say that it's very efficient and very high performance. And low level access, as I told just now, you can access memory, the processor, the RAM and everything. You can access using C, and it's very nearest to the hardware actually. And OSs like Linux, so which are actually built using C. So they programmed Linux using C. They did not use C++. Yeah, you can understand the importance of C here. And even if you use today VLC player, right? So VLC player does have some of the GStreamer components. some GStreamer, not all, but some GStreamer components it use. That GStreamer library also built using C programming language. So GStreamer library is it's a multimedia framework wherein video related things or video related applications we can implement using that library. And also microcontrollers. So microcontrollers today we are using in different appliances, right? So automobiles, in our cars, and in our in our bikes, and also in the airplanes too, for the automation, all those things, microcontrollers we code using C. And that is a different C, but that has all the features of the C that we're talking today. And embedded processors, phones, portable electronics, etc. They're all actually running some parts of C code. If you see old LCD or LED monitors, or TVs, right? If they are not Android, they run actually C. And your old TVs, so where you are just changing the channels using your remote, right? So there are also some part of the microcontrollers will be used to um, to do that operation, and which run C. And DSP processors today, you have in your phone you have all the things, which means that you can play a song, or you can play a video, or those things will be handled by DSP processors. And also there are separate DSP processors are available, especially for the video processing, entirely as a different system. So there also we use C. Most they use C. And so that is uses that will trigger your motivation to learn C. And now I just want to bring you some of the C features here. The first one is, C has few keywords. C has few keywords. And I'll talk about what are keywords going forward. And it has, compound data types, which means that you can combine two different data types, and then, you can create your own data type. So structures and units are of that type. And pointers. So you can allocate memory in the RAM, and you can allocate arrays, and those things you can access using pointers, with the memory addresses. Okay, so this is one of the great features of C. And also we have many standard libraries, for handling the IO operations, for reading from the console and then outputting out the console. And also there are some other mathematical operations, and for different other things we have other standard libraries. So it is rich in standard libraries. So that is one of the great features of C. And it compiles to native code. If you're running the compiler on ARM, then it compiles to ARM architecture. If you're running GCC on the x86 architecture computer, then it compiles to that native processor. So that is one of the great features we can talk about. And we have preprocessor, macro preprocessor, and we'll learn all these things going forward in our course. Macro preprocessor, basically, you can think of like some constants we want to define, or before compiling it does some operations. So those things will be done by preprocessor, and we use macros in order to trigger that preprocessor. Okay. And in a single in a single glance, these are the features that that I just talked now. It has some other features also which I haven't listed, but it has all the features that I just told you. Easy to extend. It's a procedure language. It runs step by step. It's very fast and efficient. It has modularity. Using functions you can make it modular. And statically we need to type. It's a very general purpose language. You can program any anything, any problem. You can program any solution using C. Okay, there are no limitations here. And has very rich functionality, very rich library of functions, and all those stuff is available. So it's a single glance of the features that we have in C programming. And I just want to mention the versions of C versions. how many versions of C software, sorry, C compiler we have today. Is first 1972 it was invented, and after that it took around 6 years to standardize this C programming. And the first spec of C, the manual of C, you can think about, that is released in 1978, and we call that C as K&R C. Kernighan and Ritchie C, we call it K&R C. In 1989 there is a new standard, 389 came in, and during that time, ANSI C, actually it has adopted the C, and it became a standard, and now we call that as C89. And after that, in 1990, it was ISO adopted, and it we call ISO C90. And 1999 a new version came up, and it was C99. And later in 2011 there is in 2007, actually before that, between 1999 and 2007, they announced they're working on working on C1X version. But finally in 2011 it came up, and we call that as C11, and previously it used to call C1X. Okay, and we have another version of C also, embedded C, which will be used to run programs on the microcontrollers and some other embedded devices, like your 8051 based system, embedded systems, and AVR based embedded systems, and those things use embedded C for operations. And next, so from here we'll just this is about a short introduction about C, and then we'll just quickly move to how to build a software. So I'll just give you some somebody asking me yeah, to go slow. Yeah, sure. Sure, I'll just slow down a little bit so that you can understand. Sorry for the inconvenience. Yeah. So now we have just saw that all the versions right now. I'll just go ahead and tell you how to build a software. I don't tell you all the things that are required. I mean, it's not exhaustive, but just brief you about how you should build a software. What are the required things that we need to take care of while building a software. Okay. Yeah. So building a software. Yeah, see this one and the left side image. Okay. So this is looking like a very, very rough sketch, right? It's a very rough sketch. We cannot deduce a clear-cut building architecture here. It just very, with a pencil, just paint, just draw some lines. It is like that. Okay. And on the other hand, see this one. Okay, right side. You see that there are many other specifications, right? So it's something like complete building. Okay, so there is entrance, and there are windows, there are doors, and on top there is a terrace, on top there is penthouse, all those things, right? Yeah, it does have all those things, which means that your software should be in such a way that it fulfill all the requirements that are given by your problem statement. And whatever problem that is given to you, your software should handle all those things. And it is not just writing the code. Okay, it's a designing the solution. It's a designing the solution, right? If you see here, the right side building looks beautiful, right? And it's like a proper building. Okay, so something like that software also need to be developed. So whenever you are writing C program, don't be hurry. Okay, don't go and type in blah blah blah, and then just don't do that. So first you need to know the problem statement, then you need to design that software. Okay, then you go for development, right? So now as I mentioned earlier about problem statement, so we need to know what is the problem that is given to us. So we are writing a software, means that we have a problem. Let's say that I want to know my electricity bill this month. I want to know the electricity bill this month, right? So electricity bill, what are the components? So there are number of units that we that we expended or that we have used for our house, right? And not only the number of units. Okay, if the range goes beyond certain limit, let us say some 50 units, more than 50 units, there is one rate. Below 50 units, there is one rate. More than 100 units, there is one rate. And below 150 units, between 150 units and between 200 units, 150 to 200 slot, there is a different rate. So I mean, we need to consider all those things I'm saying. So the problem is that try to find some electricity bill for this month, and you need to know all the problem clearly, right? So they will give you that find electricity bill for this month, and they'll say that if it is more than this thing, then use this rate. More than this, use this rate. Below this, use this rate. So you need to consider, first of all, you need to understand the problem very fluently. So that's what is required in software development, understanding the problem, which is very crucial and very important. And after that, what you need to do, you need to formulate your requirements. So what are my requirements? I was asked to build a software, and I have given a problem statement. From problem statement, what are my requirements for building a software? Okay, so number of units and rates accordingly. So those things we need to form, right? That is my requirement. If it is more than 50, then I should use this rate. So that is formulating your requirement. Know what to develop. So know what to develop. Formulating your requirements makes you clear about what I'm going to develop. And before writing a software, before just going and typing something in the keyboard, what you need to do, you need to design your software. Okay, so a step-by-step approach. You need to design a software, a step-by-step approach. This is required for very complex softwares. Okay, very complex softwares. So what you need to do, you need to, in this case of finding electricity bill, what you need to do, you need to know the number of units. You need to take the number of units from the user. Okay, and then what you need to do next. So I need to write programmatically. If it is more than this thing, I need to do this. Less than this thing, between this thing, I need to do this. So those things, those design steps you need to have before building a software. And also one more thing is, so you have designed, and next step is find out what are the features I should use in my language. Okay, so in the C there are many features, right? There are functions, there are macros, and there are command line arguments, and also there are inbuilt math operation, math operator library, and those things. So what I should use, structures, unions, everything. Okay, so what are the required features I should use from the C language or maybe any language. So I need to do. So once that is done, you need to test for a variety of inputs, different inputs. In this case of finding electricity bill for the month, what you should do, you'll give 50, 150, 200, 300. You have written software, then it will work. For example, if he gives zero, then what you should provide? You should not say zero, right? The amount of bill, the bill for this month is zero. You should not say. You can error out in a more meaningful way, right? Yeah, zero cannot be a input. Provide something greater than zero. That kind of error we can provide there. Or for example, if it is given -50, -50. So you need to test all those cases, and then you need to go back and then update your software. Okay, this is very briefly about from my experience, what I learned. So I'm just giving you about building a software. Yeah, let me know if it is still going very very fast. I can just slow a bit. Yeah, so next thing is we are just entering into programming in C. Now we will see how to program in C. So just all the things that I have told you all are till now theoretical, but now we are just entering into the practical programming aspects in C language. Okay, so before that we are going to write a software, right? So what I am using here, I'm just giving you the specifications of my hardware and software. So I'll use Ubuntu Linux, Ubuntu OS which is running in VMware Workstation Pro, Workstation that VMware, so virtual box. And so I'm using, my processor is AMD Ryzen 9. This is my processor, and we'll be using the compiler is GNU GCC. GNU basically they they develop tools for Linux and even Linux too. So they have their own C compiler, GCC, GNU C compiler, and text editor. We need to write C programs, right? So I'll use gedit, and we need to debug our software for any issues in the software, right? I'll use GDB for that. And if there are any memory issues in my program, I will use Valgrind. Okay, so these are the software tools. The last four are the software tools, and the first one also software tool, and the second one is my hardware specification. Okay, yeah. So now I'm going to introduce you to the compilation, the programming aspect, especially the compilation thing. Okay, let's say that we have a file, C file. Okay, so we write C programs, right? So the extension of the C program is .c. Yeah. Okay, the extension of the C file is .c. So in your PCs or in your file in your mobile phones, if you see .pdf, .pptx, and .txt, okay, those things, right? Something like here also, C uses its own extension called .c, which means that it's a C program, which tells us that it's a C program that is written inside. Okay, and now what we are doing here is, so this C program, okay, yeah. So before going that, I'll just give you, yeah. So this is I'm using Linux, right? So I will use commands. I will use commands to compile the software, compile the C program. Okay, compile the C program. So here, this is the command. I will tell you about what this command is in a full-fledged manner. But to know the compilation process, I'm just using. So you just just ignore this thing, but just listen here about the command, and then I will let you know everything about that command. As I told previously, right? I'll be using GCC, GNU C compiler, and then this is takes C program sources. We call them sources. This source name can be anything, sample, something else, area of a triangle, area of a circle, area of a something, blah blah blah. So you can have meaningful names should be there. Okay, meaningful names should be there. So it's a source. Its source is here, and its includes are here in this source.h, and I'm using -o, and then finally it will compile everything, these two sources as a machine code or as an executable with this name sample. Okay, this name sample. Now what are the processes that are included here? So in this process, we are seeing a simple command. It's sample executable is generated. Sample executable is generated. Then what are the steps that are involved here? I'll let you know. Okay. So when you have launched this command, the source.c will be given. The source.c and source.h will be given to the preprocessor. The preprocessor. Okay. So GCC internally they have preprocessor. Okay, preprocessor they do have, and what they do is like the includes source.c does have some includes some macros inside, and it will expand those things. It will expand those things, and that source.c after this operation will be a different one than source.c. Okay, between whatever you have written here, the code that is intact, but the includes you have or macros you have, okay, they will be expanded. Okay, for example, you have written some function here, some functionality here, then everything as is that will be available here, but the includes and macros will be expanded. Expanded. Okay, this is preprocessor will do that on that step. And next, the preprocessor, so this source.c that is generated after preprocessor will be given to the compiler, and this compiler will generate source.s, and this source.s contains the assembly language. Okay, So the assembly language, and this assembly language will be given to the assembler. Then assembler, what it will do, it will generate an object file, which is a machine code, which is in ones and zeros, all ones and zeros. Okay, you cannot read what is there inside, though you can interpret, though you can just see as a text, but some symbols you will see, but there is nothing meaningful available here. Only processor can understand. Okay, so after that it will be given to linker, right? So this linker, what it will do, so if there are any libraries that we used inside, then this linker will link them here. The definitions will be linked here, linked to this object file, and finally you will see the executable. So this executable will be used to used as a software. Okay, it's used as a software. Okay, good. Now we are going to write a sample program in C. So we'll write a program to print hello learners. Okay, hello learners. Let me just bring up my virtual machine. Can you see my Linux? Can you see my Linux? If yes, please. Can you see my Linux? Yeah, thanks. So now we are at we are in let's see course, right? So this is the terminal, Linux terminal, and from here we are building our software, which means that we are writing our C program and then we are compiling the C program. So let's see here. So nothing, there are two folders, but I want to create one more folder called sample, and then I'm going inside to write this software. So see the problem statement. See the problem statement here. See the problem statement. Write a C program that prints a hello learners text on the console. So we don't need to do anything. We just need to write a program that prints hello learners. Okay. So here I am creating a file. Let's say sample print.c. So C program should be with the C extension, right? So I'm creating sample.c. So sample print.c doesn't have anything. Touch, basically it creates that file. Okay, don't do anything. Now I'm using an editor. You can use any editor of your choice. Editor of your choice. So I'm using Sublime text editor to write the C program. Okay, to write the C program. So if you have any questions, please raise. I will answer you in the Q&A session. So if it is that urgent, if you are unable to connect between the concepts, then I'll just clarify your questions. So please do it in the chat. So it has created. Okay, it has created. Yeah, sample print. Okay, it has created a file called sample print.c, right? Okay. So before, so what it does actually, so it will just print. Yeah, this program, let's write a comment here. Okay, this program prints a text on the console. So we have comments in our C program, so that I'll explain in the next slide. Okay, to give some pretext or maybe some context about what this. Yeah, okay, Sandeep. So we are going to write a program, C program, that basically prints hello learners on the command line. Okay, we have command line, right? So here in this command line, when you run this program, should print hello learners. So something like this one, right? So you'll see a text appearing here, right? Yeah. Okay, so now we need to write what it does basically. And now so we need to include we need to write the includes here, write the includes here. So I'll let you know about all these things in the next slide. Okay, don't worry about why I'm writing all these things. Okay, and now our program, C program, starts from main. Okay, it starts from main. You might be knowing all these things, but I'm just making sure that, you know, if there is any beginner, they won't be missing out these things, right? Okay. So here what I'm doing is I'm just you know, printing hello learners. That's it, printing hello learners. So to print hello learners, we can directly use printf. We can use printf, and we can, yeah, we can write the text here. You can write the text something like this. Okay, so this is whenever you are uh, writing any text inside the code for printing, or maybe if you want to define some characters or strings, something like this, you should use double quotes. You should use double quotes. Okay, you should use double quotes. And my program returns 0 on a successful completion of the program. See, it's very simple program, right? It's very simple program. I'm just, you know, printing hello learners. I'm just saying hi to all of you. Hello to all of you. That's it. Okay. The next thing is you have written this program. So what we need to do? We need to compile this program, right? So we need to compile this program. So what should I use for compiling? GCC. Am I right? GCC. And GCC, right? And source file sampleprint.c, and, you know, my executable name -o and my executable name. So GCC is the compiler collection of from the GNU. Okay. So if you want to know some more information about the version of the GCC, you can just type GCC -- version. Then it does give, you know, what is the version of GCC currently on the system, and, you know, who owns it, all those things. Okay, right. So let's build our program. Let's compile our program. It's just sample and -o basically, you know, it does all the steps, right? It does all the steps, you know, pre-processing, compiling, assembling, and finally you'll give machine code. That's it, just machine code. Okay, that only can be understand by the your processor. Okay, right. So here it is what is it is um, showing that there is a warning here. There is a warning here. What is that warning? You know, instead of printf, I used print yes. Then it is asking that, you know, did you forget? Did you forget? Or, you know, did you forget that printf is used? Here printf should be used. So that is reminding that that is reminding us that, you know, did you forget to use printf, but you used print s. Okay, and also it is thinking that, you know, print s is somewhere else, or we have some other function print s is available in some different libraries. So to remove this error, what we need to do, just go back to your program and then, you know, make it printf, make it printf, right? Make it printf. So it's automatically happening. You just ignore. Okay, yeah. And this, you know, this n, basically this forward slash and sorry, backward slash and n, you know, it's prints a new line. Okay, prints a new line. Now just go back, and then this is your command, and then run this command, just enter, then it is done. So you didn't see anything here, right? You didn't see any messages, any errors, or any other warnings or whatever. So it has generated sample print executable, which is in green, which is your software, what it does now. Hello learners, hello learner, just prints um, that string, just prints that text. Okay, it doesn't do anything else. It doesn't do anything else apart from this thing. I told you, right? I told you that, there are different things that are there in this process of compilation. So let us look at those things. Okay. So I have created in a single go the executable, but I want to just give you an understanding of how preprocessor works, how compiler works, how it generates, or maybe the real-time um, experience of assembly code generation using GCC. Okay, so GCC has different options, -e, -s, those things. If you use, you can just create, just only stop after different steps. If you use -e here, then it just does only pre-processing. It just expand your hash include or macros available there, and it doesn't do anything. It just gives you some output, some expanded C file. Okay, and I'm just putting the expanded C file or expanded C file into a different file in order to not confuse between those two things. Okay, so now let's see. Let's see here. So we have a new file called sample print exe.c. Let's see what it does has. What it does have. What it does have. See, okay. So we have used in sample print.c, we have used hash include stdio.h. But here, see, is there any hash include thing? Is there? Did you find this thing here? No. Let's see the expansion of studio stdio.h here. Okay, the expansion of stdio.h. Just go back, just go to our function, just go to our code. Yeah, see here, this is our code. This is our code what I have written. And before this one, what we have here, just only hash include stdio.h. The preprocessor included the entire file, the stdio.h file, according to the according to what is defined or according to what is required. It has expanded here. Okay, it has expanded here. You can just about pclose. So I have opened stdio.h from the packages. You can see, yeah, see pclose. So stdio.h code is available in our simple print underscore ext.c, which means that the preprocessor, it preprocessed. Okay, it preprocessed and then it included stdio.h. Okay, right. So now we have done preprocessing. Okay, this is not required. You can just do it in a single go. Okay, single go, you can just build your software. But why I am telling is you need to know these things, what is happening behind the scenes. Okay, now let's create assembly language for this one. Okay, let's create assembly language for this one. Let's create assembly language for this one. Okay, okay, so if you use -s, okay, it will just do compilation and it will generate only the assembly code. Generate only assembly code. Okay, it is done. Let's see what is generated here. Okay, the last one, the recent one, 2017, which is 8/17, it has generated sample print.s. Sample print.s. Let's check what is there in the sample print.s. Sample print.s. Okay, okay. See here in the sample print.h s, you will see the assembly language being available here. Okay, can you understand all these things? No, it's assembly language. Okay, it's assembly language. Okay, it created, it pre-processed the code, and then the next step is the assembly language, and then after that it will create this sample print. What is this sample print have? Let's see. You cannot understand what is there in the sample print because it is a machine code. It is a binary code, ones and zeros. You cannot understand those things, right? So this is how, in the compilation, all the 3 stages you can manually do, and then you can understand what is happening behind the scenes. Okay, right. So sorry for taking long time. This is required for you to know these things under the hood, what's happening. right? Yeah, let's go ahead and let's go ahead and define the C structure of a program, structure of a C program. Okay, so in the written program, we have seen that there are comments, right? The comments which are used to tell about what this software is doing. Otherwise, people don't understand. So there must be comments for your C program, for your program. So there are two types of comments. One is multi-line, another one is single line. So single line comments you should use only using 2 forward slashes, and multi-line you should use forward slash and star or asterisk. Okay. And next thing is you need to include the required preprocessor definitions, preprocessor statements, hash include statements. There are some of the standard libraries, right? So for example, if you want to print on the console, print on the command line, or if you want to read from the command line, so you cannot do it by yourself. If you want to write, you need to write a lot of things. You need to understand the assembly language and you need to write. So you don't need to do that. So C is providing you some of the library functions that you need to use. So to use them, we need to include the required declarations or the required include files using hash include. So this hash include, it does just expand whatever you have given there. It does just expand. For example, if you give stdio.h, it expands. If you give stdlib.h, it expands. If you give std, if you give some in sample.h, it just expands. That's it. Don't do anything else. Okay. And also there are macros we can define, right? So some constants we can define using macros. Okay, so more about macros we'll learn in this course itself. And you can define a function in a macro. Many things are there. And here the next thing is function prototypes. So before writing a function, so C does have functions, right? I mean, you can write your own function. For example, let's say addition program. In addition program, so you can do that in a single line. Let's say input 1 plus input 2, that gives you some output. But if you want to do it for n number of outputs, n number of inputs, let's say n number of combinations of inputs, let's say 2 and 3, 4 and 5, 6 and 7, those things. So you just need to write a sample code which you don't need to with which you cannot repeat the code again and again. Okay, you don't need to repeat the code again and again. For that, you need to write a sample function. So for that, in order to write those modular functions, so we'll use function declarations here. Those function declarations will tell us that so we have function in this program. Okay, we have function in this program, and that prototype looks like this. The prototype looks like this. And global variables also we can will define. So don't forget about the order. It should come like this order. Okay, first comments and later hash include, and after that prototypes and variable declarations, and after that define your main function. Define your main function. So what you're going to write here, function calling, variable declarations, all those stuff we can do it here. Okay, and define other functions. So here in the third step, right? So function prototypes are there, function declarations are there, prototypes. Okay, so you need to tell what it does, or maybe you need to write what it does. Okay, so that what we call is definition, a function definition. So here a function definition will follow at the end. So this function definition can come here also, before the main also it can come, no problem. So in such cases you can escape the function prototypes, but it's always good to maintain function prototypes. Okay, right. The next thing is I want to give you an understanding of about header files. Okay, so in this in this program, what we have used here, so we have used stdio.h, right? So it's a standard IO, IO library, actually console operations it will handle, right? So so here along with this library, there are other other libraries available. Some important libraries I have listed here: ctype.h, math.h. Math.h does have some high-level mathematical operations. For example, square root. You can directly use. There is a function called sqrt. You can use square root. Stdlib does have some extra operations, like some extra features, something like a to I, argument to integer conversions, those things, and string.h for handling strings, and time.h for using time related functionalities inside your code. So these are some of the important header files that are being used in the C development C development process. So just mentioning it here. And these include files, right? So these are actually coming as a package. So these are available in the path. They are available in the path. So in here, here if you see, I haven't provided anything here. Only while compiling, I haven't provided. So where this header file is available, right? Where you see here, I haven't provided where this header file is. Where this header file is available, it automatically in the system path. So it has already taken. For example, if you have your own include file, let's say sample.h, and if it is not in the same directory, then you need to give where that is available using -i flag. Using this -i flag, using this -i flag, you can just give where this include directories, where this header file is available to the GCC compiler. And as I told, standard include directories are assumed by default. They're available by system, so they will be used. For example, let's say you have defined in the previous program, we have used the Angular braces, right? So if you use the double quotes, then first the GCC looks for this stdio.h in the current folder. Then it searches in the system path. Or if you have provided -i, then it searches there. So there is a difference between adding our custom includes and also default includes, and we'll be, as we are going through, you'll get to know all those stuff. Okay, don't worry about those things. And now we have just saw, right? Yeah, we have just saw printing some text on the console, but for example, we don't use C just only printing some text on the console, right? It's not just printing software. It is we'll use it for some doing some meaningful operations. So arithmetic operations we want to do. Then let us say there are two variables, and we want to do different arithmetic operations between those two variables. Then if you want to do addition, then you should use plus, and a subtraction between those two variables, minus, multiplication will be asterisk or star, and division will be this forward slash, and modulus if you want to find out the remainder. Then you'll find out you'll use this percentile symbol, which is modulus. So this is actually binary arithmetic. It runs between between two variables. Okay, now let's take some simple statement or simple expression, something like this. So y equal to x plus 3 multiplied by x, and the whole will be divided by y minus 4. So in this statement, you can use in the C program, you can use constant also. 3 you can use, y you can use, sorry, 4 you can use in your expression. While you are writing your software, in the C you can have constants also. Okay, and yeah, so 3 and 4 are valid in the expressions. And also, if you want to terminate this expression, so we should use semicolon, not a new line. Let us say there is a special case, right? So I want to add x and y, and then I want to put that result into x. So in such cases, this is also valid. You can write this one, x is equal to x plus y, that will be put into x. But there is another easiest way to do this one. Okay, directly using so directly using plus and equal to symbol here, you can just do x plus y, the same operation, and then assign the value to x. So for all the arithmetic operations, it is available. Okay, yeah, so we have just seen arithmetic operations, and also previously we have printed some sample program that prints basically, the text on the console. But now we are going to find, we're going to write a program to find the area of a circle, So after this one, after writing this program, we'll just stop maybe after 5 minutes, and then we'll go for Q&A session for 5 minutes, and then we'll close this. Okay. Right. So there are many things I want to tell you, but because of lack of time, so this is not going well. Okay. So so there is you might be seeing this screen. I believe the Ubuntu screen. So there is a folder called circle area. Then I'm going to write circle. Let's just remove everything. Just remove everything from here, and then write a program. Just create a program. Just circle.c, and then just do this that open that one in Sublime. Just remove everything else here. Don't need all those stuff. Then the first thing is we need to have the comments, right? This program finds, or this program does area of a circle, right? So now here what we need to do, we need to add our includes, right? stdio.h. Then next our main function will follow, right? Main, and here void. So always if you want to open, when you are opening main or any other function, so curly braces should be used. Now here so I have for finding area of the circle, what we need to know, the radius of the circle, right? The radius of the circle. So I'm defining radius. My radius is integer. Okay, and area is float. Okay, so radius, let's say I'm just defining it here, hard coding the value, radius value, let's say 5. I want to find out the area for radius 5. So what is the formula? Pi r square, right? Pi r square. So just, and again radius, right? And now I want to print this thing. I want to print the area. So the area of a circle with radius is this thing. Okay. Now percentage d is for the integer types. Percentage f is for the floating types to display on the console. Okay. Now the radius and the area, right? So now I want to return 0 after the successful execution. Okay. We have circle.c. Let's compile this thing. Let's compile this fellow. And I'm just going to say that circle area. Let's say circle area binary. And what is here? Circle area generator. And now it's circle area. The area of circle with radius 5 is 78.5. It just gave us this value. Now let's do something. Okay, we found area, right? We found area, but I want circumference also. Circumference also. I want circumference also. Let's say CF. Circumference is, let's say, CF. Variable names also should be valid and should be meaningful. Circumference CF and area is area. You don't use out or maybe something else, C, B, D. Don't use that. So your code should be readable, which means that, whatever you are giving here, the inputs and everything, which should be meaningful to the reader who are actually reading the program. Okay, right. CF. So what is the formula? 2 pi r, right? Radius. Okay. Now I want to find that thing as well. This is not the area. This is the circumference. This is the circumference. And I want to try this one. Okay. Now I want to compile. Just compile. Okay. It just created this fellow. And now I'm running file. So when you're running, this is how you run your software or your executable. Now see, the area of the circle is 78.5 and the circumference of circle with radius 5 is 31.4. Okay, so tell me what is the problem here? Tell me what is the problem here. So I'm using 3.14 here, right? I am using 3.14 here, repeated. This is repeated 3.14. For example, tomorrow something else comes up, which requires pi value, then sorry, which requires pi value, then what you do? You cannot simply using pi value, something like this. So what we can do here? Float, let's say pi and pi 3.14. So you can use pi here. You can use pi here. You can use pi here. Pi here. So there is another problem here. What is that problem? There is another problem here. What is that problem? No problem, but not a problem actually, but optimization. Okay, we don't have good optimization here. So what is what I mean is, float pi means it allocates some memory. Okay, it allocates some memory, and your program size will increase. Your program size will increase. It will work, but there is no doubt at all it will work. But the problem is, we are using unnecessarily here value for pi. Okay. So how we can avoid this thing? I'll let you know in the next slides how we can avoid creating a pi variable here in the next slides. I think we have already reached 8:36. I just want Brother Anand, should we continue or should we stop here? I'll just explain one more concept and then stop, because we have taken there that is more than 1 hour. Brother Anand, can you? Okay, I'll just explain one more concept and then we'll stop there for the Q&A sessions. Okay, now so we are doing it here area, right? And also we are basically doing some mathematical operations, okay, individually. Instead of that, we can use functions. We can make it modular. We can use functions. Okay, so there is a problem here. We are using pi, something like this. This can be avoided. So that is next step. And before that, we can use functions to define functions to make it more modular and more readable. Okay. See here in our program, previous program, right? So we have used integer and float data types. Integer and float data types. This is integer takes 4 bytes, and so it depends upon compiler. It will be 2 sometimes. Okay, float is 4 bytes, and these are the data types and their values. So you will define, you will declare those variables something like this, Okay. And now, so data types. Here are the data types. Okay, so we need to declare variables before using them, something like this. So before using radius, I need to declare it. Okay, before using it, I need to declare it. Okay, and so this is how you declare. Okay, and int for integer data types, float for floating data types, and variable initialization. So we have declared, right? We have declared variables into radius, and radius takes some value, right? So radius is nothing but it's not 0. It's not negative value. It's not 0. It has some radius value, that is, so we can declare something like this, and also we can declare during the we can define during the declaration. So this is n equal 5 is a definition. So we can define during the declaration itself. We can define during the declaration. Okay, see here. Okay, I have given this thing, right? So I just want to I just want to give it something like this, something like this. So you can do something like this also. Okay, there is no issue at all. You can define your variables during the declaration, no problem. Okay, right. So you can declare and define multiple variables at once. See here, int a, b, c, and you can define multiple variables during the declaration itself. Okay, during the declaration itself. Okay, and now so debugging a C program, I think I'm not going to cover this now. So before that, I'll just go for functions. Okay, go for functions. Just write with these functions. I'll just stop now, and then we'll continue in the next meeting. Okay, so here we are finding the area, right? We are finding the area, but see here, it seems clumsy. For example, if you want to find some, area of triangle, let's say area of triangle, and then here I need to write area of triangle and then do some operation. But instead of that, why don't you use functions? Why don't you use functions? So for functions, what is the process? You need to declare the function. You need to declare the function first. So so my function is this area of a circle, and now it ends with colon, and area of a circle takes radius. Okay, takes radius. So this is actually declaration. So here I am declaring that I have a function that will perform area of a that will find the area of a circle, and it will take one input. And it will return a floating value. Okay, this is how the declaration goes, or this is how the declaration will work. Then what I'm doing here is same. So you don't need to write it here. You can write it below here. There also it worked, no problem. Float and area of a circle, and this is radius, in radius. Okay, in radius. Then implement this here. Just implement this here. Okay, implement this here. Or you can do let's say float area here, and then what we are doing, we are returning area. So without without pre-compute also, we can directly give this entire expression here, but now I'm not doing that. Okay, I'm just, let me just comment them out, and here we don't have pi, right? So let's copy this here, pi, right? Okay, yeah, now comment out these two things. I don't need this thing because we are not doing anything here. And int radius 5 we have here, and I want to find the area, right? So let's say that area I need. Okay, area equal to area of a circle, and then provide the radius here. Okay, let's compile this fellow. This is the same. I didn't use anything. Okay, now it's created binary, and now area of circle is with radius, this thing, right? So this we did using functions. So now I just want to give you some brief introduction about these functions, right? So in the code, what we have done, we have declared that function which has return type and function name, area of a circle. Return type is float, and it takes arguments. In our case, only one argument, right? Integer radius, int radius. Okay, right. So these arguments actually here, arg1, arg2, all these are local variables to that specific function. Okay, and functions are different types. So it may have return type, may not have return type, may have arguments, may not have arguments. Based upon our need, our requirement, we can write those functions. There is no restriction at all, but you need to declare and define those functions. So here, what is declaration? So this is the declaration. This is the declaration. The line number 5 is the declaration. whereas your line number 29 to 36 are the definitions, definition of your function area of a circle. Okay, now this is more meaningful, right? Area of a circle, I'm finding area of circle. Tomorrow you come and write something else, and then circumference of a circle, and then call that function. That's it, it will be done. Okay, right? So yeah, so this is how so this is the definition, as I told, function declaration there, and function some function declaration as it is, it will come here without the semicolon for the while defining your function, and also it must match with the prototype. Okay, match with the prototype. See here, this is definition, right? So exactly this is same as this declaration. Okay, without colon, that's it, without colon. Okay, right? And variable names, only one variable is there, and while defining also it should be one variable. I mean, it must match, the declaration must match the definition while defining it. Okay, yeah, curly braces we have there, right? So they define the block and scope as well. And so if you want to run anything, we need to define variables before writing any statements. See here, so I'm going to use pi here, line number 34, I'm going to use pi, and pi I have defined, I had defined here. Okay, I declared and defined, right? I declared and I defined here. Okay, right? This is about functions. This is about functions, and the main function you have seen, right? The main function is a starting point of your C program, and it may output, may not output. You can you can have return type, or you can have void type here. So this is written actually. So this is written, and main takes some no arguments, or it can take some arguments, and with the arguments we'll discuss in further classes. Okay, so this is another variant of main, as I told. So it can take arguments also. So it can take arguments from the command line. Okay, so this is what we have till now, and there is one more thing that is left, that is preprocessors, preprocessor macros. I think I will explain that in the next session. So currently I'm just stopping it here. So we have covered till now the functions. We have covered till now the functions. Okay, so only thing that are missing here is the preprocessor macros are missing here. Preprocessor macros are missing here. So we'll touch them in the next class. Okay, touch them in the next class. Okay, now we'll open for any questions here till now in the program, or if you don't have any clarification, you are welcome. So don't feel shy about asking any question. Just need to ask. You can ask that why your faces are like that, why your voice is like that. Even that questions are acceptable, but you should ask.